Okay, so the idea is we need to be able to find the vertex of a quadratic function. Why? Because it's the maximum value if it opens down, it's the minimum value if it opens up. It's got that axis of symmetry, and we sort of have gone through some ways, right? Like we know if we have the two x-intercepts, we go right in between them. That gives us the x value of the vertex, because that's on the axis of symmetry. We plug that x value into the equation, we get the y value, and boom, now we know the vertex, right? Very useful point to know. So we have used four methods to be used to graph it, right? We can graph it with a graphing calculator, right? Or decimals. Or the decimals app. There's an app. Great, and they just introduced it for the iPhone. I'm not sure if there's an Android version, but you can get it on a browser in your phone. So if you have an Android phone, you can just go into the browser and you can go to decimals.com and you can do all this stuff. Question?
I was just wondering, are we behind now because we missed yesterday?
No, because today was a work period. So. How'd you do that? It wasn't even football yesterday.
No, I did it a week ago. I went and got an X-ray 2 days ago.
How long are you
out? 3 weeks when I'm playing night.
It's like I can have surgery in the off season. Right?
Yeah, exactly.
It's like all the guys last year. Yeah, okay. Right, my ACL doesn't matter. Just tape it up.
Wait, wasn't it work period tomorrow?
Yesterday it was a work period tomorrow. Now you have to think about that. Look at the golden method, right? Look at the. Okay, what's today? You can use a table of values to graph, right? So if you have y equals 3x squared plus 7x plus 12 or whatever, you can put in x values, get y values, you can graph it. You can use the equation in the form y equals x squared plus bx plus c using the a and c values, a for direction of opening and c for the y-intercept. Okay, and that doesn't really tell us a whole lot. Like, you can't really graph it just knowing those two values, but they can kind of help. You can use an equation in the form y equals a x minus r x minus s. So I use like b and c. Apparently I should have been using r and s. And use the r and s values as the x-intercepts and find the vertex. Remember how to do that, right? So you've got, this is r, this is s. There's your axis of symmetry. So the x value would be r plus s over 2. When you have the x value, you plug it into here. Or you might have to work out an a value, and you need one other point. You need some other point, maybe the y-intercept or something. Get the a value, plug all of those in with the appropriate x value, get the y value, and you'll know the coordinates of the vertex. To review, let's graph the quadratic function y equals x squared minus 3x minus 10 using each of the four different methods described above. Right? It's always good to go over this stuff again. So, graph y1 equals, so we need to have a calculator out. So I'm going to just pause this. Okay, we turn it on. I'm just going to clear that screen. So you go to y equals, we type x squared minus 3x minus 10 graph. Go with the default window to begin with, right? Say, it's almost good enough, right? But we need to go down a little bit further. I'm not going to bother adjusting the x's. I could. Okay, I could come in a little closer here and here, but who cares? I just need to go down a little further. So window, let's say minus 15. How do I know? I don't. I'm just trying it, right? Good enough. Okay, so this is decent. We can see everything nice. So set an appropriate window. What do we got? Negative 10 to 10 by 1s and negative 15 to 10 by 1s. Find the x and y intercepts and the vertex using second calc. Okay, let's do y-intercept first because it's easy. Second calc, value, x equals 0. Y-intercept is negative 10. Didn't really need to use the calculator for that, right? We should have known. So y-intercept is negative 10. Remember, it's just a number, it's not a point, right? And then the x-intercepts, this kind of 1, 2, 3, 4, 5. That kind of looks like 5 and minus 2. So I'm going to do this. I'm going to go into the table. and say, look, when x is 5, y is 0, right? So it really is 5. And minus 2 and 0, right? So the x-intercepts are negative 2 and 5, right? And I get that from here. If I wanted to do it from the graph, I'll just do one of them from the graph, right? So we go second. Oh, wait, I'm going to do one other thing. I'm going to go to y equals and set y2 equal to 0, and then regraph. Okay, you don't really see anything different. And then I'm going to go second calc intersect, and I'm just going to find one of them. So let's do this one, the one that's 5. So all I do is move about to the point of intersection and hit enter 1, 2, 3 times, 5. Okay, so negative 2 and 5. And the vertex is, so we go second calc. It's a minimum because it opens up. So I'm just going to scroll around. I need left boundary, so I just go to the left of the vertex, hit enter, right boundary, hit enter, and then a guess. Just move close. And we're going to call this 1.5, right? And then negative 12.25. So 1.5, negative 12.25. Okay, so this one was second calc intersect with y2 equals 0. Right, so I set y2 to 0 so I could have that line to find my zeros. Y-intercept, this is second calc value, x equals 0, and this is second calc minimum. Because the A is positive, so we know it opens up and has a minimum value. Okay, questions? No, pretty straightforward, right? I mean, graphing calculator, just make sure you know how to use it, use the second calc stuff, right? Using a table of values. Okay, I'm going to cheat. And the way I'm going to cheat is I'm going to go into the table of values in the calculator. Right? So negative 4 for x is 18. Negative 2 for x is 0. 0 for x is negative 10. 2 for x is negative 12. I've got to move down, so I need 4 and 6. 4 for x is negative 6, and so negative 6 and positive 8. Okay. Now, all of those values could be gotten by, negative 4 squared is 16, minus negative 12, 16 plus 12 is 28, minus 10 is 18. 0 minus 0 minus 10 for 0 is negative 10, and so on, right? I might be pushing things a little just because, again, I don't want to run out of time. We need to fit this in. So using a table of values, we can find those, then we can draw the graph, right, using that table of values. We know that we don't have, we know from here we don't have the vertex, right? But we do know that it goes 18, then down to 0, down to negative 12, and then somewhere it's turning around, right? Because now it's coming back to negative 6, and then to positive 8. Okay? So I'm not going to graph those points, but again, if you want to find or fill in a table of values, okay, you could do it in your calculator simply by putting it into y equals. Put it into y equals, go second function, graph, that takes you into the table. These are x values, these are your y values. These guys are all 0 because I set y2 to 0, right? So I could do the, find the zeros. Using equation in the form y equals x squared plus bx plus c and using the a and c values, not enough immediately available information to completely graph the function. However, the value of a, what are we going to say about the value of a? What's a? What number do you see here in front of the x squared? What number don't you see, but we know what the number is, right? We're number 1. So the value of a is positive 1. What does that mean? You have a quadratic that has a leading coefficient of positive 1. That means sure. Emilio, Miguel. There's Miguel. Miguel?
Can you talk to me nice, please?
Only way we'll talk to Miguel. What's positive 1 mean? Opens. Opens up. Y-intercept is -10, right? It's just the value of the constant y-intercept, right? You cannot tell much. You know, what can you tell from standard form? It opens up and here's the y-intercept. Otherwise, you're on your own, right? But yeah, whatever. Okay, if we can factor it. So in the form, y equals x minus r, x minus f. Now, if there's a number in front here, right, we usually put like an a in there, but we know it's 1x squared, so then we know the a value is 1. So we don't need it in this case, right? If it were like a 3x squared, we need the 3, you know, whatever. Yeah?
Excuse me, sir. Miguel hasn't shown up. I don't know who is.
Yeah, I don't know.
Miguel Nunez. No Miguel here? Not in this class?
Not in this class. I don't know. I don't know any of these guys. So.
Thank you.
Not entirely true. I know a few of you, but. Factor the equation. Okay, so the equation is x squared minus 3x minus 10. If it factors, we write down 2 sets of parentheses, right? We know that the first terms have to be x, because that's the only way you're going to get an x squared. We know that these two numbers here multiply to -10. And because it's negative, we know they differ by 3. So what two numbers multiply to 10 and differ by 3? 5 and 2. And one of those guys is negative and one is positive. Which one's which? Big one, right? Since the middle term here is negative, that tells me the larger factor has to be negative, right? And then just double check this, quick foil, x squared plus 2x minus 5x will give me minus 3x minus 10. Okay? So anytime you factor, run a very quick foil, just do it mentally, right? Because the thing that's likely to happen is, if you might put a 1 and a 10 there, in which case your middle term is just going to be whacked, right? It's not going to be minus 3. It's like, wait, I got 11 or I got -9 or something. That's not right. And you'll figure, okay, got to change these numbers. Or if you get these numbers right, oftentimes we flip the signs, and then you'll go x squared, and you go, wait, I'm going to get plus 3x. I want to have minus. You get out the eraser, change the sign. It's all good. So the x-intercepts are, what makes that 0? 5, and this one. Okay, so we have 5 and -2. The x-coordinate of the vertex is, okay, so think about what we have. -2, 5, right? We know it opens up. This is the axis of symmetry. How does that relate to these two numbers? It's halfway in between, right? Okay, so that this is x is equal to -2 plus 5 over 2, which is -3 over 2, or -1.5, right? So that's the big thing. This is the big thing in 20-2. The way we're going to work this is knowing that, hey, if I get 2 points on a horizontal line, then by symmetry I know the axis of symmetry is right in between them. How do we get right in between? We average the two x values. Once I have that x value, so -1.5, I go back and I substitute it in, right? And I can do that here, or I could do that here, right? It doesn't really matter. So let's do that here. -1.5, so we'll go y is equal to -1.5 minus 5, and -1.5 plus 2. So that's -6.5. And that's positive, wait, yeah, negative, that's plus 0.5. So what's that work out to? It's half of -6.5, -3.25.
Wouldn't the 0.5 be positive? Because it's right.
Yeah, -1.5 plus 2. This one here? Yeah, 0.5.
Oh, no, the 1.5.
Oh, the 1.5. Oh, you're right. Yeah, positive 1.5. What am I thinking? Positive 1.5. All right, it's going to change this then, right? Good catch. What you couldn't see was my panicked thinking of, wait, this is not going to work out the same as the other one, which we've already worked out, so we know what the vertex is, and I'm not going to get the same number. But see, that's exactly why you're here. You're here to make sure the video is good, so the people that aren't here at least have a decent lesson, right? All right, what do we get here? Negative 3.5 and 3.5, so that's negative 12.25. There, and now life is good, and thank you for that. I'm trying to figure out, did I mess up? Because I knew I messed up, right? We already knew the vertex from here. We used the calculator, so it's not like, well, why do you get a different vertex now? Okay, so there are two more methods that we will learn. Method 5, partial factoring. Okay, so this is the big thing, right? That was all review up till now. If you just walked in, you haven't missed too much. And what you have missed, this is being recorded in theory, and then you can, I don't probably see it. Hang on. Yep, okay, so this is being recorded, and you can watch whatever you've missed up to this point. But this is the biggie. Use partial factoring to graph a quadratic function is a method that can be used when it is not possible to completely factor to find the x-intercept, right? So x squared minus 3x minus 10, that factored, right? X plus 5x minus 2 or whatever. And then we get the x-intercepts, and we say, I know the axis of symmetry is halfway between them, and I take that x, but right, just what we just did. And life is good, you get the right answer. Now, this equation, we can also do this thing called partial factoring. So let's say that you can't figure out how to factor x squared minus 3x minus 10. Then you can use this partial factoring. Partial factoring works like this. You're only going to factor these two terms, right? Partial. We're only going to factor x squared minus 3x. So how would I factor x squared minus 3x? You say, what's common? X. So we're going to take out an x. And what does that leave me? Well, how do I get x squared? If I have an x in front, then I need x. And how do I get minus 3x? I need minus 3. So if you expand this, you'll get x squared minus 3x minus 10. So you see what we do? Instead of factoring the whole thing, we are just factoring the first two terms. And you can always factor just the first two terms. Look, the buses are getting here. You haven't missed much to this point, but it's all being recorded. You can catch up with whatever it was. Okay, if you look at x, bracket x minus 3 minus 10 carefully, we can find two values for x such that the y value will be equal to negative 10. What are the two values? What can I put in for x here so that this expression will read y equals negative 10? What can I put in for x that gets rid of this? 0, right? If x is 0, then you end up with 0 times negative 3, which is 0. Okay? What other value could you put in for x that would make this expression 0? So something minus 3 plus 3, right? You put in a positive 3. So what we do is we look at this partial factored form, right? And we just say, hey, you know, if I make x 0, and it's always, the number up front is always going to be an x, so it makes life a bit easy. If I make x 0, then I know that y is equal to negative 10. If I make x 3, I know that y is equal to negative 10. So what does that give me? We have 2 points with the same y coordinate, which means we have 2 points on the same horizontal line. And those 2 points are 0, negative 10, and 3, negative 10. If I have 2 points on a horizontal line, so in this case it looks something like this. Right? This is negative 10, and I have 0, and I have 3. So this is 3, negative 10, and this is 0, negative 10. So where's the axis of symmetry in relation to these 2 points? Halfway between them. So what are we going to do? So we're going to go 0 plus negative 3 over 2, which is negative 1.5. So the whole idea behind partial factoring is that we can find 2 points on a horizontal line, 2 nice points, right? Because if we have x-intercepts, they could be like square root of 12 or something. That's not a nice point. We can find 2 nice points on a horizontal line, and then say, hey, any 2 points on a horizontal line, go halfway between them. There's the axis of symmetry. That's an equation of a vertical line, but that x value is the x-coordinate of the vertex. And then use the vertex of the function and the 2 points that lie on the same horizontal line to sketch this. So now we know that x is negative 1.5. Whoops. So I can now substitute into that equation, right? Or into the original, it doesn't matter. I could take it into x squared minus 3x minus 10. I could take it into this form, right? So this would be y equals negative 1.5 times negative 4.5. Minus 10, what's negative 1.5 times negative 4.5? Why isn't this going to work? What did I mess up? Emil, what did I mess up? It's positive. It's positive, you're right. Why do I keep doing that? Because this is 3, it's not negative 3. Why am I doing that twice? You say, come on. Twice you've done this? Okay, there we go, right? Net y is negative 12.5. It's like, come on, do the math. So the vertex is negative 1.5, negative 12.25. I want a different example. I don't like this one. The numbers keep. Use the vertex in the graph. So here's the vertex, right? It's at negative 1.5, negative 12.25. To sketch the graph, so there's a sketch of the graph, right? So we have our negative 10, we have our horizontal line, this partial factoring, right? Really what we're looking for is the values of x that'll give me a negative 10 here. Yep. Yeah, we figured that out about 3 minutes ago. See? Oh, right. Good catch. See, you guys are on the ball, right? Because your job is to make sure that this recording eventually comes out correct if anybody else should watch it in the future. Which at this point are going to say, don't watch this thing. It's like full of now we're still missing a few people. Okay, let's do a different example. I hate this one. Look, different examples. More examples with partial factoring. I think I can get these right. But what's your job? Your job is to make sure I get these right. You don't have the answers in front of you here, right? You think you could get it right if you have the answers in front of you, but... Okay, so partial factored form, right? So first of all, I'm going to just start by writing it as y equals. Partial factoring says, let's take the first 2 terms. So what's the greatest common factor of 2x squared and 8x? 2x. And then I need a bracket with 2 terms in it. So what goes in here so that if I take 2x times this, I'll get this. So I get x minus 4. Okay, just run a quick check on that, right? 2x squared minus 8x. Okay, good. Minus 5, right? The minus 5 is just along for the ride. But it's what's going to give me my 2 horizontal points, right? So now I say, hey, I'm always going to have just a term with x in front, right? Like a 3x, a 2x, an x, whatever. And I say, how do I make this term 0? You always set x to 0, right? So my 2 horizontal points, I'm going to get 0, negative 5, right? So you put a 0 in for x. This becomes 0 times negative 4, which is just 0, minus 5. So 0, negative 5. Checks answers, yeah. What value of x makes x minus 4 0? Positive 4. So my other point is 4, negative 5. what's the x-coordinate of the vertex? Well, we say, look, I've got 2 points on this horizontal line, so it's going to be 0 plus 4, right? It's the average of these guys, over 2. See if I can get this one right. That's 2 over 2, which is, or sorry, it's 4 over 2, which is 2. Yeah, and positive 2. I know, right? And then the y-coordinate of the vertex is, so again, we have 2 choices, right? I can just put the 2 into here, or I can put it into here. Doesn't much matter. This is probably a bit easier, right? Because you can go 2 times 2 and then. So let's say y is equal to 2 times 2 times 2 minus negative 4 minus 5. So all I'm doing is taking this one here, that equation, and substituting x as 2. So that's 4 times negative 2 minus 5, which is negative 8 minus 5, or negative 13. And the vertex is at 2, negative 13. That one's actually right. I mean, at least it's what's written on my answer sheet. So. Okay. Okay, everybody got the idea? Again, if you're just coming in because, you know, roads and whatever, this is being recorded. You can watch it back. You'll have to suffer through the odd mistakes that are fixed. But that's how we do real math, right? I mean, we mess up and then we fix it. Y equals negative x squared. Oh, any questions on that top one, right? Okay, so let's do the next one. Y equals negative x squared. So I'm going to factor out a negative x, right? Because really what I want in here is kind of like an x, right? And then on the end we know there's a plus 6. That plus 6 always goes there. So if I take a negative x out to get negative x squared, I'm going to put an x. That'll give me negative x squared. How do I get plus 4x? What goes in here? So when I do this, I'll get plus 4x. A negative 4, right? So because I took a negative sign out, this has to change its sign. So we get negative x. What do we know? This thing opens which way? Down. So we take the negative x out, and then I get x minus 4. So what are my 2 horizontal points? And? Yeah. And again, 6, right? See, if we were in factored form, they would be zeros, right? If that was like x plus 6, and then you get the zeros, right? We're not getting the zeros, we're actually getting the 6s. Right? We're saying this is the value of x, it's going to give me 6. But, you know, it's a lot easier to do because I don't think this, you know, well, maybe that factors, but then again, you know, we don't need to be able to factor it. I mean, I guess they might factor. But who wants to factor? Do you really want to factor that? Right? You do this, that's pretty easy, right? 2x and then x minus 4. Factoring this, like, wow, I need to multiply negative 10, there's a 2x there, and I got to play with 5s and stuff. You know, and if it doesn't factor, so we don't have nice x-intercepts, then we can't solve by factoring. But we can almost always solve by partial factoring. Okay. What's the x-coordinate of the vertex? Yeah, so again, 0 plus 4 over 2. So we add up the x values and divide by 2. And so x equals 2. Is that right? Again, yes. Okay, what's the y-coordinate of the vertex? Got 2 choices, right? You can go into here, or you can go into here. Your choice, doesn't matter. So y equals negative, and I think x is positive 2, right? So it's negative x, and then positive 2 minus 4 plus 6. It's negative 2 times negative 2, which is 4 plus 6, or 10. So that's at 2, 10. Okay, so you can see now how we can algebraically determine the coordinate, because you could graph that, right? You go negative x squared plus 4x plus 6 and hit graph and all of that. But on some questions on the test, you're going to say algebraically determine, right? It might even say using partial factoring, algebraically determine the coordinates of the vertex, right? Because we need to be able to do stuff algebraically. All right. So I'm going to take out a negative 1/3 because I want to get rid of this number, right? That's got to come out. And so the idea in partial factoring is this. You always want to have bracket x, just x by itself, right? You don't want to have like a 3x in here or 1/3 x. You want to have just plain old x, which means whatever's in front of the x, that negative 1/3, that has to come out along with one of the x's. So this gives me negative 1/3 x squared. And I got to think, okay, what do I do? What do I multiply by to get positive 2? Okay, so one thing, I know it's negative, right? Because a negative times a negative is going to give me a positive. So 1/3 of what number gives me 2? 6, right? So really what you're doing is you're saying, I'm taking 2 and dividing it by 1/3, right? You know how you do fractions, right? So 2 divided by 1/3 is the same as 2 times 3. You have to flip it, right? Or in your calculator, just go 2 divided by bracket 1/3, and it'll say 6. Okay, and then the minus 1, that's along for the ride, right? That's our horizontal line we're going to find those 2 points on. One of the points is always 0, right? Because we always just take out a factor of x. So this is 0. This one is. Okay, so we get 0, negative 1, and we get 6. Okay, and then we average those two guys, right? Gives me x equals 3. If the numbers are kind of obvious, like 0, 6, I know that's 3. You don't necessarily need to show this, right? You could just write x equals 3. Right? 0 and 4, x equals 2. If they're tough, you know, if it's like negative 3 and 12 or something, then you might want to show that. Okay, so I got a 3. Are we okay so far, right? Everybody good with what's on this line? You need to practice this stuff, though, right? I mean, it's really easy to sit there and then on the test you'll go, but it looked easy, you know, when you did it. So you need to do a number of these, as many as you need to do, right? I can't tell you. You know, some of you do 1 or 2 of these, you're good. Some of you might have to do 10 or 12 of these, and you know, just get the idea. Okay, so what do we want? We want negative 1/3 x, which is 3, and then we've got 3 minus 6, and then we've got minus 1. So negative 1/3 times 3 is negative 1. 3 minus 6 is negative 3. Negative 1 times negative 3 is 3, minus 1 is 2. Okay. Again, you can work that out on your calculator, right? I mean, you don't need to do it by hand. You just negative 1/3 times 3, and just make sure you enter it into your calculator correctly. So sometimes you might want to go back through some of these examples and just sit down with your calculator and just work it out. Say, hey, am I getting the same numbers, right? Am I getting the right numbers? It's important to get your calculator skills. Sketch the 3 graphs above in the table. Verify with the graphing calculator. All right, so what do we know? It opens up and it's a bit narrower than normal x squared because of the 2. There are 2 horizontal points we know. It's 0, negative 5, and 4, negative 5, and it has vertex at 2, negative 13. Okay, so let's go down to 2, negative 13. There's 0, negative 5, and 4. And it opens up and, okay. I'll leave it to you to graph it on your own, right? If you want to verify it on your calculator, just because, you know, I want to make sure we have time to, no, wait, we're almost done anyways, right? All right, you know, here, hang on. Okay, so, let's move that up a bit. Okay, so you can see we've got the point 0, negative 5, we've got the point 4, negative 5, and we've got the point 2, negative 13. Okay, so I like this because it'll actually highlight some of the points for us. Kind of nice, right? So this graph, it's right. I mean, that's the graph. The graph that we drew wherever, here. 2, negative 13, 4, negative 5, 0, negative 5 opens up, blah, blah. Right, so all the appropriate characteristics are there. Okay, so now we want to graph the second one. which is negative x squared plus 4x plus 6. So this tells me it opens down, right? We have 2 points, 0, 6, 4, 6, and a vertex at 2, 10. Okay, so I'm just going to sketch this in. So I'm going to go to 2, 10. There's my vertex at 2, 10. I've got the points at 0, 6, and 4, 6. So on the horizontal line, 0, 6, and 4, 6. And what else do we have? It opens down, right? So, okay, so let's go graph that. If I can find, hang on, let's pause. Okay, let's move this. Okay, 2, 10, 0, 6, and 4, 6. Right there, 4, 6. We sort of saw. Okay. There's graph. Again, nice thing about decimals, you get the points labeled for you. Once you label a point, it's kind of nice. Okay, but it matches up. So we're good. And the last one, what do we got? Which way does it open? Opens down. Where's the vertex? 3, 2. So let's find the vertex first. 3, 2. What 2 points do we have? 0, negative 1, and 6, negative 1. So you notice, right? This is at 0, this is at 6, this is halfway in between, right? These are the 2 points on the horizontal line. So 0, negative 1, and 6, negative 1, right? The axis of symmetry is halfway in between. Okay, so we graph. Right? There's your axis of symmetry. Axis of symmetry is an equation, right? If I ask you for axis of symmetry, you're going to write x equals some number. That number is the x-coordinate of the vertex. Okay, let's go in here and graph this. What do we got? Negative 1/3 x squared. Can get the right tab. Okay, negative 1/3 x squared. So I want a minus 1. I want a 2x. And I want a negative, so I need a 1/3. Well, that's not going to do it. Yeah. Okay. And here we go, right? Whoops. So 3, 2, 0, negative 1, 6, negative 1. Okay. So this whole idea, right? Here's what partial factoring is all about. You factor the number and an x out of the first term. You then write down a bracket, you put an x plus or minus whatever number you need, right? So all you're doing is factoring those first 2 terms. What that does, just like factoring, right? It simply says when you make this term 0, you get the constant, which you have sitting at the end, right? So in this case, the constant, you always get the y-intercept, right? Because since you take a number and an x out, you're always saying, well, when x is 0, I get the constant, right? Which is the y-intercept. And then there's another point that I will find fairly easily, right? Because you got that just x minus 6. That becomes plus 6. And then you say, well, halfway in between these guys, 1, 2, 3, there's my axis of symmetry. Right? When I find the axis of symmetry, I have the x-coordinate of the vertex. When I plug that into the equation, whether it's the partial factored form or the original form, I get the y-coordinate of the vertex, and now I've solved the whole thing. Okay, and we have a nice graph. And if you have to do this on a test, if I ask you to do it algebraically, this is what you're doing, right? You got to show all of this work, and then you can, of course, verify it graphically, and you have to use your graphing calculator for that, right? So you should make sure, if you use decimals to check stuff, that's great, but make sure that you can do it on your graphing calculator, because that's the tool you have with you on a test or anything else. Okay, now you have 5 methods that can be used to graph a quadratic function. 2 of them are considered to be algebraic, right? So you see the word algebraic, you have to use one of the 2 algebraic methods. The algebraic method used depends on whether the equation can be easily factored completely or not. This can be easily factored, right? Which means you've got the zeros. I got the zeros, I go halfway in between them. That's the x-coordinate, blah, 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 right? And this one, cannot be easily factored. So we're going to do partial factoring. So let's do these two. Use appropriate algebraic method. You could do partial factoring on this. Like, in a sense, I say do it algebraically, and you do partial factoring, even if it would have factored normally, you're still going to be correct, right? You're just going to have maybe a little bit more work to do. So we want to graph these functions, right, and not use a graphing calculator. So what do, right? We say y equals. Well, this factors, right? X minus 4x plus 3. Easy factor, right? I need two numbers to multiply to 12. They differ, because that's negative, they differ by 1, 4 and 3. And because that's negative, the larger one is negative. Check it. X squared plus 3x minus 4x is minus 1x minus 12. Always, 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 always check your factorization. Okay? Because if you've got the signs wrong, then everything from that point on becomes wrong. Right? And then if you go and you check it with your graphing calculator and it's like, oh, it's all wrong, and then you have to redo it, right? So there goes like, oh, got to spend another 5 minutes, 10 minutes redoing this. So, all because if I had just checked that factorization, I would have caught that the signs were wrong and I wouldn't have to redo all the work. Okay, so we do this, right? Sorry, that's y equals. We have x-intercepts at -3 and +4, right? +4, -3. I have the two x-intercepts. X-intercepts are points on a horizontal line. If we have 2 points on a horizontal line, we average them together to find the x-coordinate of the axis of symmetry. Right? So at this point, we're saying, okay, so the axis of symmetry x is equal to -3 plus 4 over 2, which is 1 over 2. So we got 1/2, right? I'm just going to leave it 1/2 like that, not 0.5. Since it's exact 1/2, 0.5, doesn't matter which one you use. If that's 1/3, you use 1/3. Don't change it to 0.3 because you can't round that. It's a repeating decimal. Once we have the x-coordinate of the axis of symmetry, we plug that in to the equation, and I can use the factored form. Or I can use the original function, right? The x squared minus x minus 12. So I want the y-coordinate when x is 1/2. So just work it out. You can choose your calculator. That's -3. So I'm going to decimals now. -3.5 and +3.5. So -12.25. Okay, so the coordinates of the vertex are, well, let's go to decimals. 0.5, -12.25. Okay, you can verify that on your calculator. We're supposed to graph this. So I want to draw a sketch. Okay, let's go back, review. What do we know? Which way does it open? Come on, you got a 50-50. Which way does it open? It opens up. Okay, it has x-intercepts at -3 and 4. Okay, so it opens up. There's an x-intercept at -3 and +4. Okay, so let's label those. It has a y-intercept of -12. So there's the y-intercept. And it has an axis of symmetry. X equals 0.5. And it has the vertex at 0.5, -12.25. And we're going to throw some arrows on there. Okay, so it should be symmetrical about this line, right? It means if I put a mirror there, you look at 1/2, it's going to reflect onto the other half. Easy, huh? Right? You're thinking, okay, you need to practice this stuff, right? To whatever level you need to practice this stuff. Some of you will need to practice it a lot, and some of you will just need to do a few. But make sure you do enough of these just so you've got the process down, right? Because we got a test coming up. That's somewhere on that goldenrod sheet. It says test coming up next Thursday. All right. So that would be like in a week then, right? Okay. This one, not so easy to factor, right? Maybe it doesn't factor, maybe it does, I don't know, but we're going to do partial factoring, right? So partial factoring says take that number, -3, stick an x with it, then put down a set of brackets and put an x in here. Okay, right? So that's easy. You're just see -3 there, right? -3x, put an x there. That's a plus, but that's a minus, so I'm going to need a minus sign. Negative times negative. -3 times -4 gives me +12, and then the x. Okay. So what we're doing is we're basically just dividing this term and this term by -3. And then just write down the -5. You want 2 points on a horizontal line, so your 2 points on a horizontal line.
There's just the x.
It's really the -5 intercepts, right?
The what?
The -5 intercepts. Yeah, so what it is when I make this guy 0, right? So the idea is I need the values that are going to make this 0. When I make this 0, I'm going to get out -5.
Okay.
Okay? So 0, -5, and 4, -5. Okay, so they're not the x-intercepts, they're really the -5 intercept, right? What values of x are going to give me a y value of -5, right? Or what values of x just make this 0, right? So it's still like factoring, like here, right? We say what values make it 0? Well, 4 and -3. But they really do make it 0, right? Makes the whole thing 0. Here, it's like, well, what value of x makes this expression 0? And when I have 0, then I'm going to get -5. Okay? One of them will always be 0. Right? One of them is always the y-intercept, the other one is whatever. Right? Where's the axis of symmetry? Halfway between. So axis of symmetry. So we found 2 points on a horizontal line. If it factors, that horizontal line is the x-axis, right? And those are the x-intercepts. Otherwise, they're not. So x is 0 plus 4 over 2. So x is equal to 2. Okay, axis of symmetry is always an equation. So on a test, I ask you, what's the axis of symmetry? Don't say 2. Say x equals 2. Actually, don't say that either. Write it down. Can't say anything. Question?
No.
Okay. So some of you might have to go back and watch the whole thing, right? Which is now running at 47 minutes, or you might just need to watch the first part if you missed it, you get this, or you might be doing your homework and you need to follow through, right? So nice thing about the videos, I guess, is that, you know, if you're lost in class, or you can always go back and just watch that part and say, what the heck, and then come in and ask me, right? I mean, just come in tomorrow and just say, okay, look, just this one thing, I'm not sure about how to do blah. Okay, or go into Henry's. You can go in after school and just say, okay, I got most of this, but I'm really not sure about this one part. All right, anyway, so we got x equals 2. We substitute in. So I'm going to go into the original. Well, yeah, let's do the original. -3x squared plus 12x minus 5. So since I have the axis of symmetry, I also have the x coordinate of the vertex, and that occurs when x is 2. What's y? Well, we substitute in 2. And we can do that in the original equation. We can also do that in the partial factored form. Doesn't matter, you should get the same answer. So -3, 2 squared is 4, plus 24 minus 5, -12 plus 24, which is positive 12, minus 5, which gives me 7. So the vertex is at 2, 7. Okay. It opens down. I'm going to squeeze it in up here. So the vertex is at 2, 7. 2, 7. The horizontal line is at -5, and we've got 0, 4. So we've got 0, -5, right? We know, I mean, if that's at 2 and that's at 0, then, well, this is 2 units to the left. This has to be 2 units to the right. So from 2, we're going to go to 4. And then we sketch. Right? And the -3 in front just means this is a lot narrower than just your basic parabola. Right? There's your basic parabola. This one's narrower away to a -x, so it opens down. Okay. Negative value of a. Okay, done.